Okay, here we go. This is CP2 lesson 1. We're going to learn about circles, radius, diameter, some stuff with arcs, and then chords and secant lines and tangent lines. Doesn't that sound fun? Should I put like a little title on my YouTube video that says like must see? Would that be, what do you call that? Clickbait? Yeah, must see, circles, radii, diameters. Fun stuff, yes. Hold on, they probably can't hear anything on that. Circle, radius, and diameter. Let's get to the lesson. Let's talk through some vocab. All right, so here's some circles. What are these red segments called? What are these red segments? Apothem. It would be if it was a polygon, but not a circle. Yep. Radius. Yeah, they're a radius. Radius. And plural for radius would be, I know, radii. It's weird. How about the blue segment? That's called the diameter. And what's the relationship between the radius and the diameter? The radius is 1/2 the diameter. I like to say that 2 radiuses, or 2 radii, equals 1 diameter. Okay, so that's kind of an equation that we'll see along the line here pretty frequently. Okay, let's continue. That should be review. You've been learning that since, like, your parents taught you how to do burpees when you were 4, which is kind of late, but whatever. Okay, congruent circles. How do we know that 2 circles are congruent? Because they look like they're congruent. No, because they have congruent what? Yeah. Yeah. So in this case, how would we name this circle over here? What would we call it? Circle Minnesota. Yeah, this is circle. No, how do we name a circle? By what letter? How many points are along the edge of a circle? Well, no, not this one, but how many points would be on the edge of a circle? Infinite, right? Where is there only 1 point? In the middle. So this is circle M, and it's congruent to circle Q. That's great. So name a circle by its center. If 2 circles, what, have the same measure, then they are congruent. Well, radii. Oh, that's red. Radii. If 2 circles' radii are congruent, then the circles are congruent, and same thing for the diameters. Okay. Either one is an acceptable conjecture or statement. So far, good? Review. Okay, let's continue. Let's talk about concentric circles. What do you think is true about concentric circles? They share what? Same what? Yeah, the same center. If they share the same center, right, then it's a bullseye, then they're concentric. So if they share the same center, then they are concentric. Okay. There's some vocab there. Ooh, arcs. Arcs are fun. Arcs are paths along the edge of a circle. So here's an arc. Here's another arc. Here's another arc. Here's another arc. Here's another arc. Why did I highlight all those blue, but I didn't do this one blue? Why did I do that one red? Read. Okay, you're exactly right, Reed. The blue ones are minor arcs. What would be true about a minor arc then? Someone other than Reed. Let's define a minor arc. John? Correct. A minor arc is an arc that spans less than half the circle. Okay, that's cool. So how do we define a major arc then? Yep, cool. More than half the circle, right? I'm going to do this and this, and then just change this word to more than half the circle. And there's actually a special name for an arc that is exactly half the circle. It's called a semicircle. Okay, it's called a semicircle. So a major arc would be over half, a minor arc would be less than half, and a semicircle would be exactly half. Okay, so let me show you the classic conflict between major and minor arcs. Okay, so this major arc right here, right, and this minor arc right here, I've had students name them in this way. They called this major arc AE, and they called this minor arc AE. Which of those two would be correct? What do you think? Well, let's just take this from a 15-year-old perspective. Do you like to do less? Yeah? You like to do less. So which of these would represent less? Major or minor? Minor, right? So what we do in notation is if we have a minor arc and a major arc that would have the two same endpoints, we would call the minor arc AE. Why isn't that erasing? Oh, that's cool. Let's cross that out. We take the shortest distance from A to E, which would be the minor arc. So if we wanted to name the major arc from A to E, we'd have to include at least 1 point along the rest of that arc. So I could either call that major arc ABE, I could call that major arc ACE, or I could call that ADE. Now, some kid's going to do this because they're going to be like, I don't remember how to do this. So they're going to go A, B, C, D, E. And actually, a major arc only requires 3 letters of you, okay? So that would be overkill, right? That would be overkill. Any of those would be acceptable major arcs. So far, so good? Somebody name another minor arc. What would we call the semicircle? Out loud, say it. AD, yep. And we can call a semicircle AD or DA. If you're just like someone that likes 3 letters, I don't care. AED, that would work. Plus, that could revive you if your heart stops beating. Okay. But the semicircle, I'm only requiring you to have 2 letters to label. Cool? Okay. All right, let's continue. We got to get this smartboard thing figured out because this PDF thing is annoying. Okay. I'd like for you, see time. Yep. I want you to identify 3 of each. And I think you can only do 2 semicircles here, so let's change that to 2 for the semicircles. Work with a neighbor. Take a couple minutes. Find 3 major arcs, 3 minor arcs, and 2 semicircles. Let's go. YV, yep, sure, semicircle YV. What if you do this? Are you right or are you wrong? You're wrong. I don't know if that's like distance from Y to V on a plane, like from for a segment. I need that arc. Make it a pretty arc too. I've seen this before, you guys. I'm not kidding you. What? What is that? Are those shark teeth? I don't even know. All right, somebody else, a major arc. Someone else, major arc. Yep, cool. ZYW, I'll take it. Okay, does it have to be in alphabetical order? No. Okay, how about a minor arc? Someone throw one out there. ZY, sure. Good, cool. I'm not going to spend more time on that slide. I think that's pretty basic. Okay. All right, let's talk about what's called the central angle. This is an angle whose vertex is located at the center of the circle. So right here, I see three central angles. Okay, I'm going to call this angle number 1. I'll call that angle number 1. That was really poorly written. That's a 1. This is angle number 2. This is angle number 3. What would you say is true about the measure of these three angles? Yeah, Johnny? 360, correct. So the measure, let's say the measure of angle 2 is, I don't know, does that look like it's, I don't know, about 60 degrees? Would you agree? So measure of angle 2 should be about 60 degrees. So then this arc, the central angles measure, if this were 60 degrees, am I recording? Yes, good. Then the arcs measure, the measure of arc BC would also be 60 degrees. Cool, hi Samani. All right, how about measure of angle 3? What do we think? $160, about? Okay. So then the measure of this arc, measure of arc AC, we could say is 160. Now, for those of you at home, I don't have like this magic measurement tool. I'm just guessing along with the children in here. So like, subscribe, comment below. This is the best lesson ever. Okay, so what would be true about the third central angle? What would it have to equal? 140, right? Because these three angles, measure of arc AB, these three angles have to add up to 360. And this is called a central angle because this point O right here is in the center of the circle. That's why it's called a central angle. Oh, interesting. If an arc is a major arc, what's true about its central angle? It'd be greater than what measure? Not 90. Because I have three minor arcs up here, right? What's true about all those measures? They're all less than 180. So if I put up a major arc, its central angle would be greater than 180. So that makes sense, right? It equates to that. Okay, now chords. I like to think of this as like the hole in the guitar, right? You know how the strings go over the hole in the guitar? So if you were to look at the guitar and just forget where the strings are going, these are the strings, right? I'm not going to look at where they go to where it connects to the guitar, but those are all chords. Oh, funny. Music, chords. Funny, right? A chord is a segment within a circle whose endpoints are on the edge of the circle. So how many chords do I have in this diagram here? Let's name them. I'll name one of them for you. BD is a chord. All right, it's a segment. Name another one. BC is a chord. And the last one? AC. AC is the last one. And AC is a special one. It's the longest chord. It's the longest chord, and that chord is called the diameter. So the longest chord is the diameter. Okay, the longest chord is called the diameter. Makes sense. That's the spot in the circle where it's the furthest to get across from edge to edge. Cool. Okay, let's continue. I think our last slide here is coming up. Okay, a tangent line is a line that intersects a circle at only one spot. Okay, so it only touches that at one spot. The points of tangency up here are going to be M, point M, and point H. Those are the points of tangency. Okay, name the tangent lines. Well, I'd call one of them MA. What would be wrong with calling the other one TH labeled like this? That's not a tangent line. Why? Sean, put away your phone. Smiling's not okay right now. Yeah. No, you don't actually have to start with the point of tangency. What's wrong with the label? Yeah. Arrows. This is a tangent line, so it's got to be labeled that way. Let's see if I got anything else. Oh, the secant line. So the secant line is a chord that extends out past. So the secant line is a chord, but it's now a line instead of a line segment. So the secant line here would be line AB. And that's what we do. Like, subscribe, comment below. Pew!